This is Mr. Gilm, and today we're going to learn about compound events. Yesterday we learned about simple events. Today we're going to learn about compound events. For compound events, there's one thing that we're going to do today. It's a little different, and that's going to be making a tree diagram. We're going to make a tree diagram so we can see all the different ways that things can happen. Okay. Once we have the tree diagram made, what we can come up with is a sample space, so we can actually list out all the things that could happen. Okay. Don't forget, probability is the favorable outcomes compared to the total outcomes. Okay. What we want to happen compared to what could happen. All right, so we have a few problems here, and the first problem has to do with 3 students that are chosen to represent Mr. Baldrick's class in the school assembly. Those children are Adrienne, Greg, and Carlos. So I'm going to actually abbreviate them: Adrienne, Greg, and Carlos. Those are our 3 students. Okay. It says all 3 of them need to sit in a row on the stage. Find the sample space for the different ways they can sit in a row. And when it's asked you about the sample space, that's asking what are all the different ways that this could possibly happen. Now, there's a lot of different ways to find this, but what I would like you to do today is make a tree diagram. So to start our tree diagram, there's 3 spots. Okay, and we can have the students sit in any order. We need to figure out all the different ways they can sit in any order. So when I make my tree diagram, I try to leave some space in between when I start. So for the first spot, it could be Adrienne, or it could be Greg, or it could be Carlos for the first spot. Now, if Adrienne is in the first spot, that means that Greg could be in the second spot, or Carlos could be in the second spot. If Greg is in the first spot, then Adrienne could be in the second spot and Carlos in the second spot. Or if Carlos is in the first spot, then that means we could have Greg or Adrienne in the second spot. So if it goes Adrienne, Greg, then the last person would have to be Carlos. If it goes Adrienne, Carlos, the last person would have to be Greg. Greg, Adrienne, the last choice would be Carlos. Greg, Carlos, Adrienne would have to be last. Carlos, Greg, Adrienne would have to be last, or Carlos, Adrienne, then Greg would have to be last. And so this is called a tree diagram. It's just a mapping of the ways that things could happen. Our sample space actually comes from the tree's roots. So we could go Adrienne, Greg, Carlos. We could go Adrienne, Carlos, Greg. We could go Greg, Adrienne, Carlos. We could go Greg, Carlos, Adrienne. We could go Carlos, Greg, Adrienne. Or we could go Carlos, Adrienne, Greg. And so you can see all the different ways that this could happen. We have 6 different ways that we could line these 3 students up. So when it says find the sample space, this is the sample space. We've now answered the question for find the sample space. Now it says what is the probability that Adrienne will not have to sit by Greg? And so what we're looking for is any time that an A is not by a G. Well, this one, there is an A by a G. This one, Adrienne is not by Greg. This has an A next to a G. This one, Adrienne is not by Greg. This has an A by a G, and this has an A by a G. So it looks to me like we have 2 instances where Adrienne is not sitting by Greg, and there are 6 things that could possibly happen. So I know that the probability of Adrienne not having to sit by Greg would equal 1 in 3, okay, or 1/3. All right, let's take a look at another one here. On the second example, it says that a caterer made sandwiches for a company picnic. Each sandwich was made with rye, sourdough, or white bread. So I'm going to abbreviate those: rye, sourdough, or white bread. Okay. Each sandwich contains either ham or turkey. So I'm going to call these guys ham or turkey. It says show the sample space of all the possible sandwich combinations. Okay, well that's what I'm going to do first. I need to list out all the different ways that we can make sandwiches. And so again, I'm going to make a tree diagram here down where I have a little space. And I need all the sample space, all the different things that could happen. So Let's start with the bread types. I could start with rye, sourdough, or white bread. Now, if I choose rye bread, I could have a rye with ham, or I could have a rye with turkey. If I choose sourdough, I could have a sourdough with ham, or a sourdough with turkey. And if I have white bread, I could have a white ham or a white turkey sandwich. So now remember, sometimes we get a little confused. We're not going to have two slices. I mean, there is an element of common sense. Each sandwich has one type of bread and one type of meat, okay? Not two types of bread. So we're not going to mix R's and S's. So one type of bread, it could be rye ham, or it could be rye turkey. Or we could have sourdough ham, sourdough turkey, or we could have white ham or white turkey. Okay, so there's my sample space. When it asked me to write the sample space, that's all the things that could happen. That's my sample space. The second part of the question asks, if there's an equal number of each sandwich, what's the possibility or probability of choosing a turkey sandwich on sourdough bread? So we're looking for ST is what we're looking for. It looks to me like there's one turkey sandwich with sourdough bread out of the 6 different ways we can make our sandwiches. So my probability will be 1 in 6. Okay. In this case, it says suppose you toss a quarter, a dime, and a nickel. Find a sample space for all the possible ways 3 coins can land, heads and tails. Okay, now these questions can be a little confusing sometimes because it says quarter, dime, and a nickel. Honestly, they could just say 3 coins because a quarter has a heads or a tails. A dime has a heads and a tails, and a nickel has a heads or a tails. Okay, and so regardless of what type of coin they are, each one has a head or a tail. Okay, so it's just 3 coins. So what we're going to do is we're going to start with our tree diagram. So let's just, and this one's going to take a little more room because it's a little bit bigger. Let's go ahead and see if I can scroll down a little bit and make some room. Then we'll come back up when we need to. Okay. So when I flip the first coin, regardless if it's a quarter, a dime, or a nickel, there's 2 things that can happen. Either I could get a heads or I could get a tails. That's on the first coin flip. And again, it doesn't matter which coin I flip first because each of them have either a heads or a tails. The second coin I flip also could be a heads or a tails. It doesn't matter which coin is flipped second because every coin has both a heads and a tails side. So I could flip the first coin and get a heads, flip the second coin and get a heads, or I could flip the first coin with a heads, then a tails, or the first coin flip could have been a tails. So this is like the first coin flip, the second coin flip, and this will be the third coin flip. I could flip the first one, get a heads, second one, get a heads, third one, get a heads, or I could get a tails. And again, for each of these, I could get a heads or a tails after each of these flips. Okay, and there's my third coin. And again, it doesn't matter which order because they all have both a heads and a tails. And so this is called a tree diagram, but what we want to find is the sample space, all the different ways that we could have the 3 coins land. So I could land with all heads. I could land with a heads, and a tails. Or I could land with a heads, a tails, a heads. I could land with a heads and then a tails, then a tails. I could have a first coin flip of a tail, then a head, then a head. A tail, a head, and a tail. A tail, and a head. Or a tail, and a tail. So a lot of times students think there's only 6 different things that could happen because we have 2, 4, 6 different heads, tails. But really, as you can see when I make my tree diagram, that there's really a sample space of 8 different outcomes that could happen. Okay, so when it says find the sample space, that's what this is. These are all the things that we could have happen. The probability of getting 3 tails is, okay, so what we want to happen compared to all the things that could happen, it looks to me like we only have one example of when it's all 3 tails. I don't see any other that are all 3 tails, so we have 1 in 8 different ways it could happen chance of getting 3 tails in a row. What's the probability of getting 2 heads and 1 tails? Okay, now 2 heads and 1 tails can be confusing because there's a lot of ways this can happen. We could do heads, heads, tails, or tails, heads, heads, but there just needs to be 2 H's and 1 T. Okay, this one does not have 2 H's and 1 T. This one, I'll use a different color so we can see. This one does not have 2 H's and 1 T. This one does have 2 H's and 1 T. This one has 2 H's and 1 T. This one does not have 2 H's and 1 T. This one has 2 H's and 1 T. This one does not have 2 H's and 1 T. This one does not have 2 H's and 1 T. And this one does not have 2 H's and 1 T. So as I look, I see that 1, 2, 3 of them have 2 heads and 1 tail. And that's what we want to know, 2 heads and 1 tail. So really we have a 3 in 8 chance of getting 2 heads and a tail on our 3 coin tosses. Finally, it says the animal shelter has both male and female Labrador retrievers in yellow, black, or brown. So after I read that first sentence, I am going to abbreviate M, F, and we could have yellow, black, or brown. Okay. There's an equal number of each kind. Show the sample space below of all the types of retrievers available. So let's start with our tree diagram. The dog could be either male or the dog could be female. If it's a male dog, it might be yellow, it might be black, or it might be brown. If it's a female dog, it could be yellow, black, or brown. And so now that I have my tree diagram, I can easily see what the sample space is. It could be a yellow male, a male that's yellow, a male that's black, or a male that's brown. We could have a female that's yellow, a female that's black, or a female that's brown. And so there's my sample space of all the possible ways to get a retriever. The probability of choosing a yellow female out of my sample space, well, here's the yellow female. I don't see any other yellows that are also females, so I would have a 1 in 6 chance to choose a yellow female. Okay? So this is a compound event. It's when there's multiple ways that you can, or multiple combinations of things happening. And so hopefully at the end of this video, you'll be able to make a tree diagram and be able to write the sample space from the tree diagram, as well as know that probability is what you want to happen compared to all the things that could happen. And that's it for today.